Okay, I want to go over some examples, review examples, and we'll go on to the next item on the agenda. Okay, solve the inequality and graph your solutions. So you have negative 2x minus 4 greater than negative 16. So I need my number line to plot my answer and represent the answer correctly. So there's only one sign, so I don't make any kind of table. The x is on this side, on the left-hand side. Okay. Now between the negative 2 and the x, there's a times. Between the x and the 4, there's a minus. We'll make it plus negative. Now, again, when solving inequalities, you want to highlight or circle multiplication or division. And if there's a negative, you're going to put an S for switch. So that sign will need to switch because eventually we'll have to divide each side by that negative. But there is a step we have to do to get rid of the negative 4. So when I get rid of that, I need to just line up the original sign. So I plus 4, negative 2 times x, negative 16 plus 4 is negative 12. Then I divide each side by negative 2. And I have x, negative 12 divided by negative 2 is 6. So I plot 6. Remember, if it opens towards a number, that means it goes this way, because that means x is any number going that way. Okay, next problem. We have 15f plus 9 is greater than 3 times the quantity 5f plus 3. Okay, so we need to use the distributive property to multiply my parentheses. So I've got 3. Now I'll multiply it by 5f first. And then I will multiply it by the 3. Whatever's before the plus, whatever's after the plus. So 3 times 5f is 15f. 3 times 3 is 9. So I line up the symbol, and over here I now have 15f plus 9. And over here I have 15f plus 9. Okay, now you have f's on both sides, so you don't highlight the operations yet. You take the smaller one to 0, but there's no smaller one, so that means this becomes either all solution or no solution. And we can get rid of the number line, we don't need that. Okay, so I have the same number, 9 and 9. There's no equals to line, so then that is a no solution. If the equals to bar was there, it would be all solutions. Okay, go to the next page if you have a packet. If not, keep writing. Negative 1 less than or equal to x minus 3 less than or equal to 2. Now when I have two symbols in the same problem, two inequality symbols, we're going to make our number line, but then we're going to make a table to make it into just one. So I put less than or equal, and then less than or equal. So we're going to put negative 1, and then I'm going to put that with the expression x minus 3. Then I'm going to put 2, and I'm going to again put that with the expression x minus 3. This time x minus 3 will come before the value of 2. Okay, so x is on this side. The operation would be a minus, which will make it plus negative. So there's no multiplication or division. Okay, we just have to get our negative 3 to 0. So add 3, that's 2, and that's x. Negative 3, so plus 3, we got x and 5, okay? So we have 2 and 5. You're going to circle, you're going to need to shade them both in. And then here it's opening towards the x with the 2, but it's opening towards the number, the value with the 5, so then that combines into 1. So I put x in the middle, 2 on one side, 5 on the other. So again, when that combines into 1, 5 is the maximum, so you have to open up towards that. And then 2 is the minimum, so don't open up towards 2, because x is bigger than 2, so x, 2. Okay, then we have 2x less than or equal to negative 4, or 7x greater than or equal to 49. So again, there's two different symbols. We'll need the number line over here, but then we again make the table, and it's already in separate inequalities for us. We don't need to separate it like we did the last problem. So you have 2x less than or equal to negative 4. And then we have 7x greater than or equal to 49. So 2 and x, that'd be 2 times x. Okay. So again, you want to definitely circle the times. That's a keep. Okay, keep the sign the same. And we don't have to add or subtract any numbers. We go right into the division. So I have x negative 2. Now over here, here's the x side. The operation between 7 and x is times. So again, that's another keeper. Okay. And we do not have the number outside, so I can go straight down here and divide by 7. So I have x and 7. So my negative 2 and my 7 are my two values. We would fill them both in. Here it's eating the negative 2, so that's this way. Here it's eating up the x, so that would be the other way. Okay, go that way. So then that's an or, just like the original problem. So x less than or equal to negative 2. X greater than or equal to 7. Okay, now to the new assignment here today. This is kind of the last assignment of this unit, and it's been a long unit. Okay, solve the inequality and graph your solution. Okay, we have the absolute value of x less than 5. Now with absolute values, you want to definitely make a table off to the side, okay? Right there. Don't make it underneath. Okay, so within the absolute value, we have x, okay? Then I make a d, okay? So here's what I do. We just have d and then 5 on the other side. So I can go right to my table, okay? The distance is less than 5. But a funny thing happens. You're going to put less than, but over here, you're going to put greater than. And I'll explain why you're going to do greater than here in a second. And the two possible distances of 5 on a number line are 5 and negative 5. Now I'm going to explain why we flipped the sign here. Okay, you can just watch. So the distance is less than 5. What that means is the distance is less than 5 from 0, okay? So you'd move towards 0 from each of your sides, okay, because less than. So moving towards 0, that way is going to be less than. But I also need to move then here, and going that way is greater than negative 5, okay? So that's why. Less than 5, is this way, but then that way is greater than negative 5. Basically, you need to just remember to flip the sign. Now, x is already solved for. I mean, you can make your wall, but there's only just the x over there. So now you go to your number line, and you plot those values along with 0. So you have 5 and negative 5. Remember the rules. You're not going to fill in either one because there's no equals. Now this is open towards the value 5, so that would be this way, but this is open towards the x, so that would be this way. Now to label it, you got x, minimum, maximum. 5 is greater than x, so you got to eat the 5, okay? And then x is always bigger than negative 5, so you eat the x, okay? Alright, my next problem, we have the absolute value of x greater than or equal to 2. Now when solving for variables in the absolute value, you make a table. You're going to put x and x, because that's all you have inside. So you put greater than or equal, but then you flip it over here, less than or equal. So the distance is greater than 2. The distance is already solved for, okay? So I put 2 and negative 2. Now again, let's illustrate why the sign flipped, Okay. Now that is a greater than sign. So that means, just watch this, that means the distance is greater than 2 from 0. Okay, so that means you'd move away from 0 on each side because the distance between the number and 0 would grow. So that's greater than 2 that way. Okay, but then I would also move away from 0 that way. But going that way is less than negative 2. So you got to remember to just flip the sign when you do the negative. A lot of people forget that, but you got to remember. So you put 2, negative 2. You're going to fill in both circles. And then again with 2, when I go to 2, it's opening towards the x. So that would be out this way. It's opening towards the value negative 2. So we go this way. And now we have an OR graph. Okay. With OR you put x on each line and you just copy down your answers. Definitely want the D variable here. Okay, so we have the absolute value x plus 8 greater than or equal to 3. So again, with absolute value, you want to make your table. What's inside? This time it's x plus 8. So I write that on both sides. And I use the original inequality there, but then I flip it over here. Now let's box up the absolute value and put D. So D is greater than or equal to 3. D is solved for. So I put 3 and negative 3. Okay, so x has an operation this time. Okay, so we have to get the 8, just a plus operation. So no dividing or multiplying. You just subtract 8 from both sides. We have x, negative 5. Okay, x and 8, there's a plus, so just circle the x and you minus 8, minus 8. You have x, negative 3 minus 8 is negative 11. So you want to graph those. Now we weren't graphing on these absolute values yet the last lesson because they were just equals. They're just equations. So it's open towards the x there. And it's open towards the value here, so they combine into 1. So x, negative 5, negative 11. Or no, wait, I messed that up, I'm sorry. Made no sense. Both of them here, negative 5, negative 11. I apologize for that stupidity. Okay, so with negative 5, it's opening up towards the x. With negative 11, it's opening towards the value, so they go out. Okay, so OR, and you just put x on each line on an OR. And with the 11, you just write what you have, less than or equal, and then greater than or equal to negative 5. Sorry about that dumb mistake. Okay, absolute value of x minus 2, less than or equal to 1. So mark what's in the absolute value, it's x minus 2, and then less than or equal, and greater than or equal. So let's turn that into a D. D just got 1 there, so we can go right over here, 1 and negative 1. Okay, the operation between the x and the 2 is a minus, so we'll make it plus negative. And we just can circle the x then, and we just have to get the negative 2 to 0. So plus 2, plus 2. So I have x, 1 plus 2 is 3. Okay, same thing here, except instead of 1 plus 2, it's now negative 1 plus 2, which is 1. Okay, so we have 3 and 1 is kind of the range, so 1, 3. So we fill in each circle. Okay, it's eating the value there, and it's eating the x here. Okay, so again, that combines into 1. So I put x, 1 on this side, 3 on this side. 3 is always the bigger one when compared to x, so it's got to open up towards 3 with the line. X is the bigger one when compared with negative 1. Okay, we have the absolute value of 2x minus 5 less than 9. So within the absolute value, we have the expression 2x minus 5. And then less than and greater than. Okay, so you got d and 9, so 9, negative 9. Now you solve it. X is on this side. Between the 2 and the x is a times. Between x and 5 is a minus, so plus negative. You want to circle the times. That's a keep, okay? Now in the middle, you got to get your negative 5 to 0 in the middle, so plus 5, plus 5. So 2 times x, and then 14, divide by 2, we have x, 7. Okay, over here, 2 and x is times, so again, that's a keep. But in the middle, we have to get the negative 5 to 0, so plus 5, plus 5. So negative 9 plus 5 is negative 4, then divide by 2, and you get negative 2. So 7 and negative 2. Okay, so it eats the value, it eats the x. Don't fill in either one of them, leave them open because the lines aren't there. So negative 2, 7. Okay, next one. Absolute value 3x plus 1 greater than 8. So within the absolute value you have 3x plus 1 greater than and less than. So d and 8, so you got 8 and negative 8, so let's solve it, okay? So we got times and plus, circle the times, but that's a keep. Minus 1, so again you got 7 now. Don't go down to that last sign until after you've divided by the 3. So you got x. Now if I divide 7 by 3, here's what I get. Not a fan of that, so second PRB, 2 1/3. Okay, so I got times 3 plus 1, that's a keep just like the other side was. We got a minus our 1. Now it's negative 8 minus 1, which gives me a little better number to divide by 3. So I have x, negative 3. So we have 2 1/3, and we have negative 3. Both circles are empty. So with the 2 1/3, it's open towards x, so it goes this way. X and 3, it's open towards the value, which always takes a graph that way. So it's an or. Greater than 2 1/3, less than negative 3. You just copy basically what you ended up with on line. Okay, last page. The absolute value of 4x plus 1 greater than 11. So you have 4x plus 1 greater than, less than. So we have our distance greater than 11. So 11, but then less than negative 11. Okay, so x is on this side with a times 4 and a plus 1. So the 4 is positive, so that's keep the sign the same. We do have to get the 1 to a 0. So minus 1, 4 times x, it's 10. Then I divide by 4. I have x, 10 divided by 4 is 2.5. Okay, times 4 plus 1. So I'm minus 1. Oh, first off, that's a keep. First off, when you have multiplication, you got to decide at the end what you're going to do with your sign. You'll keep it. Keep it the way it is. Negative 11 minus 1 is negative 12. So you have x, negative 3. So I got 2.5, negative 3. So opens to x that way. Opens to negative 3 that way. So you got or. Okay. Last problem's a little bit tricky. You do have number 5s like this. You want to put number 5 on the assignment. Number 1 through 4, you're pretty much just doing what you do. The D is already solved for you. Go to the table. But this one here, okay, number 5, you're going to want to go back and check. Because this is a little interesting. Now in the absolute value you have x plus 2. So you start off with greater than, less than. Now what's weird about this is your D has operations to it, okay? In the previous problem we just had D and oh, there's a number over there I can use for over there, but now I can't. So D in the front is multiplied by negative 3. If you want to slash that out you can. Then you have to add 4 greater than negative 14. Now you have to find out what the D would be. So you make a wall, you have times and plus. Now just like with x, when you have D times a negative, that's a switch. So you got to switch the sign because you have a negative multiplier. If that was positive 3, I wouldn't be switching it, but it's negative 3. Now we have to get the 4 to a 0, so we drop the original sign because I'm just going to minus 4. When I'm minusing and adding, the sign doesn't switch. It's not till I divide by the negative where it flips. Negative 14 minus 4 is negative 18. Then I divide. Since I'm dividing each side by a negative, that's why the inequality is flipped. So I have D and 6. Now another thing you got to do. Since the sign has flipped, you need to flip these signs. That will be greater than. Excuse me, that will be less than. And that will be greater than. Okay. So again, we had to switch the sign because of the multiplying by negative. So I had to divide by negative, so it flips there. So we're less than 6, but greater than negative 6. So I put the signs there to begin with, but when the sign ends up switching, then they both switch over here. Okay, now you got x, no multiplication operation, so I just have to get the 2 to a 0. That's 4. No multiplication, get your 2 to a 0. You don't worry about the keep switch if it's no multiplication or division, okay? So negative 8. Plot of your answers. So you got 0, you got 4 on one side, negative 8 on the other side. Okay, neither one gets filled in. With the 4, it's eating the value, so this way, it's eating the x here. So that's what you end up with. So you got x, and then negative 8, 4. 4 is the bigger than anything, so anything has to open up towards that. And negative 8, x is bigger than negative 8. Okay. So, there you go.